Hello everyone, I am Dhaval Desai. Welcome to my HL7 fundamental video series. In this video series, I'm getting a deep dive into HL7 introduction, HL7 message format, and what are the different kind of messages HL7 generates while transforming clinical or healthcare information between the systems. So let's get started. Before we jump into the HL7, I would like to provide a brief overview of my professional background. I have more than 16 years of experience in healthcare IT industry. I worked as a solution architect or cloud architect for many healthcare organizations. Worked on various HL7 standards, worked on cloud technology like AWS, GCP, Azure, delivered many successful projects in healthcare IT industry. So in this series, what I'm covering, so in this particular video, I'm covering the common terms used in healthcare IT workflow or RCM workflow, healthcare teams involved, what are the different systems involved in the healthcare, why we called is as HL7 or health level 7, how the HL7 interfaces are designed, advantages of using HL7 and HL7 message format. So let's get started with the common terms used in the healthcare IT or interoperability world. First one is the electronic health record. The electronic health record is nothing but a digital version of paper chart. Uh, in the old days, the paper chart has been used, and then when it moved to the electronic version, it's called electronic health record. HR are a patient-centered record that provides the authorized users with the immediate and secure access of the information. It consists of like patient's medical history, diagnosis report, prescription report, treatment plans, immunization, allergies, radiology images, and so on. Same thing, electronic medical record. Electronic medical record is also a digital version of paper chart, but it's used in a single clinician's office. Uh, the difference between EHR and EMR is EMR is mainly designed for one office, and it doesn't travel between the practices. Uh, the next one is a practice management. Practice management or practice management software is typically designed to help healthcare providers to manage administrative and operational aspect of their practices. So it's basically day-to-day operations such as finances, billing, scheduling, communication. Those kind of things comes into the practice management software. Uh, the next one we see is ICD-10 codes. ICD-10 is basically the name itself suggests like International Classification of Diseases or International Codex of Diseases, that version 10. So it's medical classification list by World Health Organization that contains the codes for diseases, signs, symptoms, abnormal findings, complaints, social circumstances, and external cause of injury and diseases. CPT is a current procedural code. It's similar way the ICD-10 code. It is like current procedural terminology code and are assigned to the each task and services that you will get from the provider. So on the certain activity or task happens in the provider's practice environment, that gets a CPT code, and CPT code gets entered into their practice management software or provider software. Uh, the next one is health information exchange, integrated health enterprises. Interoperability we will deep dive into much more detail in the further slides, but it is basically ability of information systems to exchange the information between multiple systems. HL7 or health level 7 is a set of standards for sharing, exchanging, integrating, and retrieval of health information between multiple healthcare systems. And that's what we are doing in this video series. We are studying HL7 into much more detail. PACS, a picture archiving and communication system. Mostly it holds the X-ray or medical images, which so patients' medical and X-ray images will be get stored in the PACS system. HIPAA, Health Insurance Portability and Accountability Act. There is a separate video I recorded on HIPAA and high tech, which basically covers the importance and basics of HIPAA for the healthcare or startup organization. You will see the link below in the description. PHI, Protected Health Information, ONC, M Health, and HHS. So there are many healthcare IT terms, but I covered here some of the important ones which we will discuss in the video series. Okay, let's understand clinic and hospital workflow. So patient comes in to the front, meets the front desk staff for the routine checkup, and receptionists and start collecting the patient information like demographic information, insurance details, and then eventually in the next step, once front desk staff receives the information, gets stored into provider portal, then uh, front desk staff books an appointment, and before the appointment, uh, patient portal or clinic contacts the insurance company for insurance verification and pre-authorization, sorry. And then eventually all this information gets stored into EHR. If there are any lab required during the patient appointment, if doctors or any routine checkup or labs, it goes to the lab. The order gets placed into the lab, and once the appointment is complete, it goes to the charge capture process, coding process, then claims and billing, and finally the gets closed. To understand this complete flow, how it starts and completes this process, let's understand the complete revenue cycle process in terms of healthcare. We'll take the example of John Doe. So, a patient John Doe calls a healthcare provider to schedule an appointment for routine checkup, and front desk staff collects the name, contact information, demographic information, and insurance details. Then registration on the day of registration on the day of appointment, John Doe arrives at the clinic, and the front desk staff completes the patient intake, which includes the verifying the John's insurance, collecting any necessary copays, and updating the John's demographic information. Goes to the charge capture for the service after the checkup, and the healthcare provider assigns a medical procedure and diagnosis code for the encounter. This code includes the general checkup code, blood test code, and relevant information uh, based on the appointment or the whatever the provider finds out. Once those charge capture process is done, next is goes to the billing. Uh, Billing in the billing department creates a claim based on the codes and assigned during the encounter, and this claim gets sent to the John's insurance company. Insurance company uh, gets claims get submitted to the insurance company, and the insurance follow-ups up happen. If insurance company goes really well and gets everything paid, then it's good. Otherwise, it goes to denial management. A claim denied by the insurance company for any reason, the billing department reviews the denial codes and determines why the claim is denied, and makes the correct necessary correction and prevents the denial for the future. Sometimes it goes to account receivable. The billing department identifies the follow-ups and unpaid charges. Then this could involve the contacting the insurance company for the unpaid claims, John's reaching out John for the outstanding balances and all. And finally, it goes to patient reconciliation, and the case gets closed. The patient reconciliation, basically the payments and adjustment writes off, and account balance gets resolved. So that's the overall revenue cycle management process, which happens in the real world. So, what are the different healthcare teams are involved? When handling this practice management system or electronic health record, there are different teams are involved. Primary care is one of the first one where we saw the John Doe contacted uh, the front desk staff and came for the regular checkup. There are other systems like lab, radiology, pharmacy, community care, emergency room, inpatient care. It depends on the patient's need, or that depends on the different scenarios. This system gets contacted and the data gets stored. So, so all these teams, what are the different systems they are using? So, lab system is the laboratory information system. Radiology is the radiology information system, or data information system. Pharmacy is pharmacy management system. Electronic health record, electronic medical record used at multiple places in the primary care, inpatient care, emergency room, community care, and long-term care based on their requirement. And each of their EHR provider might be same or it might be different based on how they onboarded their system and at what time they onboarded the system. So what's the actual problem? So when all these systems are involved, when where the practice provider systems gets trying to transfer the data into the lab or trying to order the lab, and also transfer the demographic information from one system to another, contacted the insurance provider, these systems are designed separately. Their databases, their schemas, or their whole infrastructure designed separately. They might be compatible with each other, they might not be compatible with each other, and there is a intermediary or intermediate layer or steps required to transfer the data from one system to another. And that's why many systems are still broken and they're not compatible with each other. And this might happen with new onboarded app. So if new apps gets onboarded into the system, they have to again connect with all these system one by one and create adapters which will transform the data from one system to another. Is that a big problem? Yes, it is. So in healthcare IT, or you would say any IT industry, basically there are three layers or four layers or architectures are designed. The front layer is the UI layer or the browser app where the actual physician, clinician, or providers uses the app. The intermediate system is basically a business processing or technical transformation layer, and the backend is the database layer. For all these systems, they host their own database, and their database design implementation are completely separate, and sometimes it doesn't even match with each other. And that's where the problem comes, and this problem is HL7 is trying to resolve. So, how it is trying to resolve this problem, before we go there, let's understand the HL7 layers and their details. So, HL7, the name comes from Health Level 7. It works on the OSI level 7. So, seventh layer of OSI model, Open System Interconnect model. Uh, so, before I discuss on seventh layer, let's understand the common seven layers of the OSI. So first layer starts with the physical layer, which is at the bottom. The physical layer is nothing but the interconnection of the physical wired or hardwired between the devices, where it transmits the bits from one device to another. The next one is the data link layer, which is responsible for the node to node delivery of the message, and it delivers the message from one node to another. Third layer is the network layer, one where it breaks the segment into the network packets and resembles the packets on the receiving end. So basically, it divides the packet from in the source end and in the receiving end. It basically reassembles the packet and resembles the packet. Fourth one is a transport layer, where it takes the data, gets transferred for the session layer and breaks into segments. Transport layer's main job is divide the data into segments, and it reassembles at the receiving end. Session layer, as the name suggests, the layer 5, it creates a session between source and destination, and it keeps the session open until the data gets transferred from one session to another, one from source to destination. Presentation layer prepares the data for the last layer, which is the application layer. And last but the most important one for us is the application layer, where end user software or end user SaaS software works in browser or in the client's machine. And it provides a protocol that allows software to send and receive information and present in the meaningful way. And that's the reason HL7, Health Level 7, is using application layer. So health level 7 applications are electronic health record, medical imaging system, clinical data, decision support, and other healthcare softwares. Health level 7 emphasizes the importance of understanding the unique requirements and challenges involved in the communication and exchange of the health information. And that's where HL7 plays the role in the center. It helps to exchange the data in a standard format which will be compatible with the other systems. And so, what is it? HL7 is the standard protocol. HL7 is nothing but an organization which developed a different standards. And the most famous one in HL7 is HL7 version 2.x. but there are others. So HL7 standard, the very first one, HL7v1, was established or published in 1987. HL7v2.x is published on 1988. HL7v2.xml 1999. V3 is in 2004. HL7CDA is another one which we will discuss in some other later videos. Uh, HL7 CDA is mainly focused on clinical documentation uh, side, and Fire is the most latest one, where Fire version R4 is industry wise used nowadays. HL7v2 is mostly used in other countries. I think in India it is HL7v2.5 to 2.8. UAE is using 2.5. And most of the countries is using 2.x version because it's mostly adopted by the different systems and it's compatible with each other. What are the advantages of HL7? Ability to share medical demographic billing data with HL7 enabled applications. So what are the applications is HL7 enabled? That's easy to transfer or exchange information from one system to another. Data transfer in the form of messages, as we saw this before. So HL7 basically prepares a data in the form of message and transfers from one system to another, and get that message gets decrypted at the other end. How all this process happens, we'll see in future videos, like in the Mirth Connect video, where how we connect two different systems, how we receive the message, decode the message, and basically many times we have to store the additional messages and process it one by one. We'll discuss that in more detail. Connect any to any system. HL7 connects any healthcare system to any system, so it works designed in a such a way that it will work for considering the future compatibility of the systems. Why we this HL7? Probably at this point, everybody understood why we need this. It's a common way of communication between the multiple systems, and it enables interoperability. Obviously, it maintains the quality of the data. And okay, so trigger events. What is the basic methodology to transfer the HL7 messages from one system to another, and how it actually works? So trigger event is the main, uh, I would say, main methodology, or main flow. So if we consider our example of John Doe, where he came to the front desk staff did the check-in, collected the demographic information, then scheduled the appointment, then eventually after the appointment ordered the labs and updated the medical code before billing and claims. So all these are considered as a trigger event, where the event gets triggered from one system to another and the information gets transferred between those systems. Okay, before we deep dive into HL7 message format, let's understand interoperability. I mean, many organizations talk about it, but what is the actual meaning of interoperability? Is just transfer of information from one system to another system? No. The actual interoperability or digital interoperability basically gets divided into three parts, and all three parts are required to achieve accurate digital interoperability. The first one is a technical interoperability, the another one is a semantic, and the last one is a process interoperability. Let's study one by one into detail. So technical interoperability is the ability different information technology infrastructure systems and software application to communicate and exchange the data. How to identify? uh, Basically, we need to do a proper architectural selection, whether it's on-prem, cloud, or hybrid solution gets implemented for the organization. Authentication and authorization. This is the most important one, where we have to implement authentication and authorization. There might be a different way to implement this, but proper authentication authorization is required in the technical interoperability. And messaging and document standards has to be adopted. The second one is a semantic interoperability. Semantic interoperability is the ability of system to exchange the data with unambiguous meaning. So let's consider the example here, the ICD-10 code. shows the acute bronchitis is a J20. And the same thing in for the SNOMED, under SNOMED CT, it shows in a different code format, whether 10509002, and NDF-RT format is completely different. So these kind of interoperability or understanding the clinical data properly has to be important while achieving the interoperability or exchanging the information. And the last one, last but not least, is a process interoperability, and which is the most important one while transforming the information. The ability of diverse clinical processes to work cooperatively and to interoperate by merging their functionality at the certain shared element and points. So let's consider the example here. Here on the left hand side is a clinical information system and lab information system, where the pre-admission encounter is created in the clinical information system, and patient data and all the demographic information has been captured. And as soon as it gets captured, the trigger event gets generated, and it transfers the information to the lab information system. Once if in between the patient information gets updated, gets changed accordingly, the another trigger event gets created and information gets transferred between the system. If clinician is ordering a lab test for the patient, that creates a separate event, and that event gets recorded and transferred to the lab information system. Then lab process that event, generates a result. Once the results is generated, the event comes back to from LIS to CIS, and CIS system receives the lab results in their system. So uh, combining this technical, semantic, and process, we can achieve a better digital interoperability between the systems. So let's deep dive into the message format. So how the HL7 message looks like. HL7 message is basically uh, it's a top level message, and under the message it's a segment, field, component, and sub component. But just to understand how actually it looks like, I'll provide an example of our closet probably. Let's kind of understand a message is kind of our closet. Under each closet there is a racks or compartment, racks or shelves, I would say. So each shelf considered as a segment, and under each segment, under each shelf, we consider fields as their compartments. So field is nothing but a one compartment under the shelf on that level, on the similar line. And under each field you can then do a component and subcomponent, where you can basically divide your stuff in a such a way that you can differentiate uh, that stuff, differentiate between the component and subcomponents. So on the high level you have a closet, then each segment is considered, you have one segment is for the pants, one segment is for the shirts, another segment is for your socks, and then under the segment you kind of divide the fields. So you each field is nothing but your divide the shirts into formal shirts, t-shirts. Those are different fields, and then each field again gets subdivided into components and subcomponent. Then HL7 message delimiters. HL7 message delimiters are nothing but uh, while designing the HL7 message, these delimiters are used to properly decode or encode the message. So encode the message from one end and decode at the another end. So for each segment, the first one is a segment terminator, where we use the carriage return as a delimiter. So carriage return is basically the end of the segment, and how it is, I'll explain in the further slides. The field separator is basically one field to another field. To differentiate the new field is getting started, we use this field separator. Component separator, subcomponent separator, repetition separator, escape character, these are some of the important delimiters we used, and it is very important to understand this to at least design a basic HL7 message. This is the sample HL7 message, how it looks like. So this is a complete one HL7 message, which is further get divided into segments. And these segments are MSH, EVN, PID, NK1, PV1, PV2, AL1, GT1. And this segments then further gets divided into fields, and if you see, the fields are divided by the pipe symbol or pipe sign, msh. Then if you will find the pipe sign on your computer with the backslash character on the same key. uh, you will see here on the slide, the right hand side explains what is msh. Is a message header. It usually comes with every HL7 message. Then event PID is a patient identification. There's a detail about the patient, date of birth, and their address, and all this detail. You see, we saw the example of John Doe. Similar, it's covered here. uh, Diagnosis information, procedure information. So this is the HL7 message looks like. Yeah, I think we covered a lot detail in this video. So the remaining detail I kept for the future videos, like in-depth HL7 message study, different structure of the message, how to build the actual message, how to build an interface. Then we'll go into the HL7 engines or interoperability engines like Mirth Connect. Mirth Connect is one we covered because it's open source. Database readers, multiple destination, fire, etc. If anybody wants to actually explore this practice management software or the patient portal or the providers portal, you can visit this site. This is open EMR, where it gives you look and feel of the system, and there are some open source components are covered. There are many other systems like Epic, Oracle, Cerner. Those are much more complex than this, but this is, I mean, it's good to start with. And yeah, that's it. If you have any other questions, feel free to put it in the chat below. And if your organization or if anyone wants uh, help with the interoperability, feel free to contact us, and our team will happy to help with the interoperability needs for your organization. Thank you. Thank you for watching this video.